Hi, everyone. First review video of the year. So if there's some clunkiness to it, just realize it's the first of the year. But the thing we can't screw up is I need to share my screen. Once I share my screen, everyone can see the problems we're about to do. Let me make sure I'm doing that right. Oh, yeah, I think I am. Let's see. Yes, I am. Boom. All right, I'm going to do every single one of these problems on here. Ooh, oh, gotta get my pen on. Getting my pen on, you know what I mean? All right. So, got my pen on. Let's go. Why is Miss Cass in the background? Hi, Miss Cass. Oh, here, mirror image. Happy birthday, Miss Cass. That was my background last year, so we're just keeping it because it's her birthday. Party like it's her birthday. Oh, wait, to start the first video of the year. Now we're ready. First sound effect of the year. Won't be the last. Okay, what's happening here? We are arithmetic. Why do I know that? Because we're subtracting. Right here, we are geometric. How do I know that? We're multiplying. Right here, I don't know at first glance. So if I do 5 divided by 10, that's 1/2. 2.5 divided by 5 is also 1/2. So I'm geometric because I am multiplying by 0.5 every time. Here it looks like I'm going up, but I'm actually going down. It doesn't matter. I'm going down by the same amount every time. That is -4. So this is arithmetic. I know I'm talking fast. The point of this is that I am checking your work. So if you need to slow me down, you can hit the slow motion. I'm just joking. Hit the slow motion button. Or if you want to speed me up because I'm not going fast enough and you think you can go through these a lot faster, then do that. Skip to the ones that you want to work on the most. Do them as many times or as few times as you want. This is at your pace. If I go too fast, watch it again. But don't just watch this video. You should be doing this on your own and checking your work and correcting anything that you need to correct. Okay, so let's look at the. Did I skip one? No, I didn't. Okay. So if I'm going 10, then 20, then 30, I'm going up by exactly 10 every single time here. So this is arithmetic. Number 6, we get 10, then 20, then 40, then 80. We are multiplying by 2 every time. Therefore, this is geometric. Little 50-cent humor there with this coin problem. All right, let's look at the next one. So, someone looked at this and said, hey, I see a multiplication symbol. That must mean that we are geometric. Not so fast, my friends. To be geometric, you need to, yes, multiply. But you need to multiply by the same growth factor every time. This is not multiplying by the same growth factor every time. You're multiplying by n. N is changing. It's a variable. So for the second step, you would multiply by 2. For the third step, you would multiply by 3. This is not multiplying by the same thing. So does this fit the geometric definition? Multiply by the same growth factor every time? No, it doesn't. Not geometric because the number we times by changes every step. Okay. As n goes up, the number you're multiplying by is going to go up. So that is problematic to our label there. So that person was wrong, but we still love them. Okay, let's look what's happening here. How many white squares did you have? On my paper, I actually marked them so I could see the number. And when I did count that, I counted 8 in step 0. I counted 13. I counted 18 in the next. And then I didn't have step 3 and 4, so I just looked at this pattern. What's happening every time? I'm adding 5 every single time, which means this next step, step 3, is going to be 23, then 28. Recursive equation to represent this. Well, I have a 0 term, so I am going to write a 0 term. I'm just using my formula sheet here. I have a 0 term. The formula sheet says that if I use a 0 term, I need to state it, which is 8. And then after that, and I know this all looks like a different language, like Mathanese, but what is happening here is we take the previous term, this is the symbol for previous term, and we're adding 5. When does that happen? That rule works for all the terms after 1. So all that is a fancy way of saying we're starting at 8 and adding 5 every time. Okay. Follow your formula sheet. All right, non-recursive. Let's change colors for the non-recursive just so they are clear away from each other. So you have your formula sheet in front of you. Okay. And you can use your formula sheet for this, but you also can use your former knowledge from Algebra 1. Okay. What is happening every time here? You're going up by 5. So, and where did you start? At 8. This is just asking for a slope-intercept equation. 5n plus 8. Okay. 5n plus 8. Are we going up by 5 every time? Yeah, that's why we have 5n. Did we start at 8? Yes, we did start at 8. Now, if you insist on using your formula sheet, if your slope-intercept may disappear, get my formula sheet, got to take the elevator down to go get it. Check the time. Elevator was broke, took the stairs, gave me back. Okay, so if I wanted to use my formula sheet on this one, I just look at it and I can see that it's a slope-intercept equation there. Okay, but if I insist on using the formula sheet here, we can just say, okay, what's A of n or W of n? Let's stick with W. W of n is equal to the 0 term, which is 8, plus n times the difference, which is 5. You get the same thing either way, 5 times n plus 8. But me, I just look at your slope-intercept background. Your intercept is your starting point. Your slope is that common difference. All right, using a method of your choice, show your mathematical work. In this case, I mean, you could have just continued with the table. The choice for me right now, I'm just going to replace n with 10. Fill it out, plus the 8 there, and I would say it's 58. So the 10th term is 58. Okay, that's one way of showing my work. Another way I could have shown my work is I could have just 6, 7, 8, 9. That 9, I'm not sure why I made that one so big. Could have just kept going along this pattern, in which case I would be at 33, 38, 43, 48, 53, 58. So this table also, 10th step, this table also shows my work. So the only, an example of something that wouldn't work is just you writing the number 58. That's not enough. You need to show me how you got 58. Okay. Don't tell me it's common sense. There's nothing common about what you're doing. You're doing difficult things. Show me what's happening. If it's in your head, put what's in your head on the paper. If you did it in your calculator, don't write, I put it in my calculator. Show me what you typed into your calculator. All right. Why does 8.7 not make sense? Because we're going up by whole steps here, okay? We can't have part, won't have part of a square to cover, right? So what's happening here, every time we add a black square, we're covering it with 5 additional white squares. Well, if I add 0.7 white square, it's not like I'm going to partially cover that, right? So that doesn't make sense to go up like that. Sometimes, like if you're working a job and you work half an hour, you'll get half your hourly rate. That makes sense. It doesn't make sense to take part of this pattern and cover it at the same rate that you would. Okay. Okay, onward. All right, so we are taking 2/3 away every single time. I'm going to go ahead and add a 0 step here because I like to think, hey, I started with an entire cake. And then I started eating it and goodbye cake. So 2/3 of it goes away, which means 1/3 of it is left. So I'm not just taking 2/3 away, I'm not subtracting that. What I've done here is I've multiplied 1 by 1/3 to get here. Okay, which means I'm going to continue to do that, multiply by 1/3. And now I would have 1/9 of the cake, multiply that by 1/3, and now I have 1/27th of a cake once I've done this process. An nth term non-recursive equation to represent this, okay? Well, we could say two things. We could either say that we are doing 1/3 to the power of n, okay? And then again, because if I take 1/3 to the power of 1, I get 1/3. This even works for the 0 term. If I do 1/3 to the power of 0, everything to the power of 0 is 1. So that actually works even if we go backwards to the 0 term. If you want to follow your formula sheet, okay, you can also do that by writing the first term, which would be 1/3 times your rate, also 1/3, to the power of n minus 1. So either of these would be acceptable answers. Hmm. All right, in both these next two questions, it's asking for words, recursive and non-recursive descriptions here. So in words, what I would say is we start at -20, and then we go up by 3 each time. Okay. Now, if I'm describing this recursively, I would say, how would I say start at -20? I'm going to go with a 0 term here, okay? And I'm doing that because I like a 0 term because then I can use that as my y-intercept for the next part. So recursive. Okay, so if we say recursive, we'll say that this is a 0 term of -20. And for all the terms after that, not -2, -20. For all the terms after that, we take our previous term and we are adding 3 every time. That rule exists for the first term and beyond. The only thing that would be different here, if you called this a first term, then that 0 would need to change to a 1, and that 1 would need to change to a 2. Okay. I like calling it a 0 term because it helps for my non-recursive. Because I like to say, hey, where did I start? That's my y-intercept, as you learned in Algebra 1, right? So you're just writing it in a different way. You're just writing this equation or this function as function. We used a before, so let's use a again. A of n is equal to 3n minus 20. You got your y-intercept, got your slope, just like you had before. Okay. Now, you could also use your you could use your formula sheet if it doesn't stick out to you, right? If it doesn't stick out to you using your old slope methods, you can use the formula sheet, but the same thing results. Let's even call this a well, I don't want to call it a first term necessarily. You could just say, because you have a zero term. If you want to use it as a first term, talk to me, talk to your teacher. But this I like to use the zero term because then it works out in terms of the slope intercept effect method, I should say. Okay. So what is happening here? Again, with words, I would say that we start at 10 and then we multiply by 10 every time. All right. The words really help, I think, with the recursive definition, because when you're looking at your recursive definition, you're just looking, okay, where is my starting? Again, I'm going to continue to call this the zero term. Okay, so recursively, well, we did the last one with the zero term. So let's just, for the sake of practice, let's call it a first term. Let's see if anything really changes that much. So our first term is 10, and what we're doing is we're taking our previous term, and instead of adding or subtracting this time, we're now multiplying. This time we're multiplying by 10. Instead, before we had 1 because we called that a zero term, but now we're saying it's a first term, so we'll say this works for all the terms 2 and beyond. Okay, so we'll stick with this method for non-recursive, or use the other way that it's referred to, the nth term. Okay. So if we stick with the nth term, right? If we are looking at this as a first term, so again, you have a of 1, right? So let me just write this out. So what you're looking at on your formula sheet is a of 1. Sorry, start that again. You look at a of n equals a of 1, which means your first term, times your rate, times n to the power of r to the power of n minus 1. Okay, so this is what's on your formula sheet. But what you have, you actually have a first term. Okay, so you need to replace a of 1 with what your first term is. Your first term is 10. So because a of 1 is 10, 10 goes there. Your rate is also 10. So 10 is going to go inside the parentheses instead of r. And minus 1 up top. Okay. Now, if you considered that a zero term, okay, if you considered that a zero term, again, you can talk to, well, the zero term's a little something different here. So we'll just call that the first term. All right, we'll say that's the first term, and it's 10. Your rate is 10. So let's think about, for example, how do we get the first term here? Well, 10 to the power of 1 minus 1. 1 minus 1 is 0. 10 to the power of 0 is 1. 1 times 10 is 10. That's how you get your first term. That continues to go on. Okay. So let's see. Let's look at 5, 9. 13, 17. We have two options here. 4n plus 1. Okay, 4n plus 1. Or could also look at 5 plus n minus 1 times 4. Okay, so I'm going to push you a little bit here and actually think about what you've done in your previous math classes where you have to distribute this number that you're multiplying here. Okay, so 4 times negative 1. Let me rewrite this. C of n equals 5 plus n minus. Yep. That 4 gets multiplied by the negative 1, so you got negative 4. 4 also gets multiplied by n, so you have 4n. And then you have a 5 hanging out here. 5 plus negative 4. These are your like terms. Well, 5 plus negative 4 last time I checked is 1. So this is actually saying 4n plus 1. These are the same formula, okay? So we are both correct. Because this is the same formula written two ways. Okay, something I like to do with my class is I like, as I've said before, I like for these things to be vertical. It just helps me out. Okay, so if I'm thinking, okay, and we've got our first term, our second term, third term, and fourth term. We have 4 terms listed for us. Oop, I drew an extra line there. We can ignore that. Our first term was 5, then we went 9, 13, 17. I like to draw this table because then I can think, okay, I can go backwards. If I'm going up 4 every time going forward, I want the 0 term because the 0 term is my y-intercept, your old school y-intercept. If I go backwards to that 0 term, my y-intercept would be 1. Because if it's plus 4 going forward, well, then it would be minus 4 going backwards. So that's how I found my y-intercept to confirm this formula again. So these, who's correct? They're both correct. They both did the same thing. Yeah, hey, everybody gets a prize. Isn't that special? Okay. Recording. But if I'm not recording, then no one heard that. If no one heard that, who am I talking to? Whoa. All right. Okay, recursive and nth equation for this. Again, we're switching it up. Sometimes we're going with a 0 term. Sometimes we're going with a first term. Right here, we have a first term. So let's stick with using first term. Non-recursive. We're switching between non-recursive, nth term, slope intercept. All these things kind of mean the same thing. So forgive me if I'm using them loosey-goosey. 2 to 4 to 8. Maybe I didn't realize what was happening here. So I had to go new divided by old to get my growth factor. So I went 32 divided by 16. That's 2. And 4 divided by 2 is also 2. Okay, so what's happening here is I'm multiplying by 2 every time. So recursively, I would say my first term is 2. And for every term after that, I take that previous term and I'm multiplying it by 2. That rule exists for all the terms after and equal to. Non-recursively, again, we have a first term. We have a first term, so let's go to the first term one and first term is 2. Our rate is also 2. Go to the power of n minus 1. This works might work going backwards, but we're only giving these ones, so we'll say it starts at the first term and goes beyond that. Okay, last problem. Yeah. Okay, so man, my screen's messing up. I can't see that sequence, so I'm gonna rewrite it again. So we got 4, 8. Okay, this is saying it's arithmetic. Arithmetic means that we're adding the same thing every time. So what would, using a method of my choice, hey, it's getting late. So you know what? I'm the method of my choice. I'm just going to keep listing these until I got my 10th term. 4, 8, 12, 16, 20, 24, 28, 32, 36. My 10th yet? 1, 2, 3, 4, 5, 6, 7, 8, 9. My 10th is 40. Is that right? 1, 2, 3, 4. Yeah, it's 40. Come on now. Okay. So that's all the math I need to show right there. I could have also realized that, hey, what's happening here is I'm just doing 4 times my step. So I could have done 4 times 10 and got 40. That both of those are acceptable ways of showing the 10th term. All right, the next one is saying that, oh, wait, we are going to look at this as geometric, which means I'm not just adding 4 every time, I'm multiplying by 2, which would be 4, 8, 16. Multiplying by 2 every time is going to get me a little higher than before. Ugh. 2, 64, 28, 256. 512. This is the method of my choice. I've done enough equations. I don't want to do an equation right now. I can do an equation if I want to. But right now, I'm just being asked to show 10 terms. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2048 looks good to me. There's your 10th term. So S of 10 equals. All right, people. It's been real. It's been fun. It's been real fun. Actually, right here, I couldn't think of a good joke because I was drawing a blank. Get it? I drew a blank. That's a blank. Wah, wah, wah. All right. Can I stop share? Let's stop recording. Yes, we were recording. All right, everyone. Good luck on the test. Bye. Hand in your reviews. Peace.